Hi, so here is another example under line integrals. We still have to evaluate what we have here. Okay, so I believe if you have watched the two previous videos that I've done under line integrals, you understand and you agree with me to say these are like they are very basic. These questions are very basic. It's just a matter of um, doing what is supposed to be done. So in this case, we can say our x of t is simply equals to t, which is what we have here. Then our y of t is also t. Then our z of t is simply equals to t. And I can say I'm suspecting a very basic answer for this one, looking at what I have here. Okay, it doesn't offer something that is a bit complicated, but of course this is just going to give us a constant, so we're not really high on that one. So x prime of t is simply equals to 1, and it's the same as y prime of t is the same as z prime of z prime of t. All of them are equals to 1. Okay, looking at what you have t, and you have t there like that. So it simply means you can say the square root of that would be like 1 squared plus 1 squared plus 1 squared, that would be equals to the square root of 3, like that. Okay, so having that constant, let's go ahead and substitute. So we have a 3. So it simply means I can say I'm evaluating. Of course, we have been given the interval from 0 to positive infinity. Okay, then here I'm going to say I have the square root of 3. Okay, then we say divide by where this x, you substitute with what x is in this vector valued function, and x is equals to t, same as y, same as z. So this is just going to be like you're supposed to have like t squared plus t squared plus t squared, which of course is just going to give us 3t squared. So it's that we have 3t squared. Okay, then here uh, remember, here you're supposed to multiply by the square root of x x prime of t, then of course you square it. And what we have already done this part, actually I don't even have to put it here. We have found what we have found root 3. So we say square root of 3 there, then multiplied by, well, let me just say dt. By the way, this was supposed to be ds, sorry. Then we have our dt there, like that. Okay, so here you observe to say you can multiply square root of 3 by square root of 3, you end up with a 3, then you cancel out with this 3 on the denominator. So this is just going to be like 1 to positive infinity, then you have like 1 over t squared dt. So this is very simple. You don't have to think of some complicated method of integration. All you have to do is just say, okay, you are still moving from 1 to positive infinity, then you can just take this up, and this is going to become t to the negative 2 dt. Okay, integrating that, remember what we are going to do is that we have t to the negative 2, so you add the power, like you increase it by 1, you do the same on the denominator. Okay, so it actually makes sense to say you are increasing, because you know that you have like negative 2. If you add the 1, this is going to increase to what, to negative 1, because negative 1 is greater than negative 2. So that's why you're talking about increment when you're talking about integration. Okay, so we really have to pay attention to the signs to really understand what we mean by increasing and decreasing if it was derivatives. So meaning this is just going to be, if you add the 1 there, that's going to be negative 1. Okay, so it will be like t to the negative 1 divided by negative 1. So this again I can just take it on the denominator, so that will be like minus 1 over t. So it's like I'll just put the negative here, then I'll say 1 over t there, like that. So evaluating from 1 to positive infinity. Okay, so this is going to be equals to minus, I'll say 1 over infinity minus minus 1. Okay, so 1 over infinity is simply a 0. Okay, so it's like you're going to have negative 1 multiplied by negative 1, which is going to be equals to a 1. So the solution for this question is a 1, positive 1. Okay, so that's what we get for this question. Thank you very much for watching.